Awesome, thank you everyone for coming. I think this is the biggest turnout we've had in a little while, which is nice to see. I'm just going to do a really quick introduction. This is going to be a little bit freeform. I mean, it always is a little bit freeform, but we've kind of got lots of little bits of presentations through this. So I put a rough agenda together that I shared yesterday, but to be honest, we'll see how that goes and where a break feels appropriate. So very quickly, Sam's just going to give us a quick introduction to Agilent, who are kindly hosting us today, and talk a little bit more about the future plans for that towards the end. Petru going to give us a quick talk about it wasn't a VI plugin, was it? It was like a menu plugin or in LabVIEW. And then James is going to show us a log file viewer. So he did a great presentation at GDevCon on some UI stuff, and yeah, he didn't get this far, so I'm going to share it. Oh, that's probably about the right time for a break. So we'll take half an hour to be able to have a chat. Mike, if you're still okay to talk about it, but sorry, I was a bit slow getting back to you. But we talked about it before anyway. And then I want to talk a little bit about memory layout. So this is kind of my early thoughts for something that hopefully I'm going to do for the GLA Summit. So it's very rough, but it might be interesting. And then just want to wrap up with kind of an update on the plans for CSLUG, the kind of things we're thinking, because it's all obviously changing quite rapidly at the minute. So, and I didn't check, hopefully everyone can hear us on the streaming. They'll have seen me waving around by now, so if they can't hear me, they probably commented.
Yes. Sound is good, yeah.
Sound is good, excellent. So I will let you jump in then, Sam, and that's down. No, isn't it?
Okay, so yeah, just a couple of like quick housekeeping things. There's no fire alarm scheduled, so if it does go off, make your way outside. Toilets are just the next corridor along, so the one parallel to this, out, left again. Yeah, help yourself to refreshments and stuff at the back. And yeah, there's a coffee machine, like vending machine thing. It's free, so help yourselves if you feel the need for a coffee. But yeah, I thought, and I can ask James about this, but I thought as we're kind of hosting in different places, it might be interesting for people to get a feel for what we actually do here as a team of LabVIEW developers. And obviously, I'm hands up if you've heard of Agilent. and hands up if you've heard of Agilent because of things like multimeters and benchtop instruments. Okay, so that's what we're not going to be talking about too much today. So yeah, but yeah, so I'm the R&D software manager of the LabVIEW team here, and yeah, I'm going to dive into this. So yeah, Agilent as a business, yeah, listed on the US stock exchange, lots of different products, technologies, and that kind of stuff that we look at. Over 16,000 employees worldwide. I think we got certified as a great place to work last year in the UK, and yeah, we kind of all over the world. So quite a big global organisation. This site is part of our spectroscopy and vacuum solutions division. So we've got our site here in Oxford, but also we kind of have a sister company that works in Mulgrave in Australia, and other kind of parts dotted around. I'm going to look to my team to correct me when some of this is inevitably wrong. So yeah. The context then, so yeah, we're looking at spectroscopy, which is using visible and non-visible measurement of the electromagnetic spectrum. I'm going to gloss over that because I'm not a spectroscopy expert. There's other people in this room that know far more about it than I do. So yeah, go and ask them. But I think this is kind of interesting because it kind of shows you how that move from Agilent doing benchtop instruments to what Agilent is today. So kind of started off as part of Hewlett Packard. doing instruments. And then basically in 1999 was when kind of Agilent was born. They kind of spun off that measurement side of the business into a separate entity, and then kind of over the last sort of 15, 17 years, kind of re-scoped, kind of what they want to do. So moved away from sort of, benchtop test and measurement stuff that we do in, yes, work.
Benchtop test and instruments spun out in 2014 to become Keysight, or 2013 to become Keysight. So that's the split.
Yeah, so that was where it then split away again into the benchtop stuff as a separate thing. So now it's kind of more focused on kind of like life sciences, pharmaceutical instruments and that kind of stuff. So, higher end instruments rather than, the kind of test and measurement stuff that, we is our kind of, bread and butter as LabVIEW, people. So in terms of the molecular spectroscopy, so a lot of this stuff on the left-hand side, doesn't really apply to this site here. The key thing that I kind of wanted to bring in here was that in 2017, the team here, worked as part of Cobalt Light Systems, and then that was acquired in 2017 and became kind of part of Agilent. To basically deliver the sort of Raman spectroscopy side of our instruments. So that's kind of, these guys down here. Molecular spectroscopy portfolio. So again, the kind of the stuff on the top right is kind of the stuff that we deal with here on this site is the Raman and transmission Raman spectroscopy instruments, but kind of between us and the Australian site, we cover quite a broad range of spectroscopy techniques and that kind of stuff. Uses, pharma. I think for us here, this site, pharma and security detection are kind of the two key areas that we look at. So goods incoming detection, and then things like airport security products, explosive detection, customs, that kind of stuff. How does LabVIEW fit in? Our Raman spectroscopy products, they run LabVIEW. Our handheld instruments, I think there's something like 350 of those deployed worldwide with a small embedded PC, and that runs our LabVIEW software to perform those functions and that kind of stuff. So we have a team of 11 LabVIEW developers, a few architects, CLDs, and a mix of half full-time staff and half contractors. One of the things that we're kind of working on over the last couple of years is working towards becoming a LabVIEW centre of excellence as well. We've come quite far on that journey. We have a regular internal user group, so our next one of those is on Thursday, so user group heavy this week. Trying to work on kind of working towards that centre of excellence process. I left this in, I thought it's kind of interesting, but spectroscopy comes from the Latin word for ghost, and scopos, which is watcher. So essentially, if you're a spectroscopist, you are a ghost watcher. And that came from Newton back in 1666. I quite like that as a little thing to finish on. That was very quick, but any questions? I didn't check these slides from our R&D director before, but I hadn't noticed until like 5 minutes before the session started that that was one of our their instruments upside down following a fatal catastrophe. Cool. So just a very quick introduction as to kind of what we do as a a team here, and a team of LabVIEW developers. I think it's a bit different that we're kind of writing LabVIEW to go on a physical product, and kind of the interesting challenges that comes to. Whereas a lot of things tend to be one off of something or a few off of something, but actually product that's out there in the hands of customers, I think is a little rare for LabVIEW. So
cool. Thanks, Sam. That's great. I was just saying to him at the start, it's one of those things. Because I used to be at NI, I know what a lot of these companies do because we visit them and see them, but I realise there's probably not a lot of knowledge between people of what actually do outside of a user group. So that's good. So Petru, if you're happy to step up. There. So the little handheld units, it's like a fully fledged PC. By which I'm assuming an Intel processor.
Hello everyone. My name is Petru. I'm a certified LabVIEW architect, and I'm happy to see so many familiar faces, but also quite a few new ones. Let me start the slides. Okay, should do it? Yes. So I work for Siemens Mobility in Chippenham, working on railway infrastructure equipment together with my colleagues Bravi and Dan. But recently I also started my company, Robusto Systems. So this is a small community tool I've been developing in my own time in the last few months. Yes. So what it is, it's a right-click menu plugin, meaning it's an IDE extension that appears when you right-click on certain items in LabVIEW. This is a possibility that was introduced only about, I think, 5 years ago, relatively recently in LabVIEW, but I think it's a great addition to the environment because it gives us developers and regular users the ability to kind of create our own little tools that then naturally integrate into the LabVIEW environment. So yeah, I think it's a pretty cool thing that NI have done. And this particular tool is meant to help people create new VIs and new controls, type defs, more quickly. It's only a very, very small thing, but I find myself doing this obviously repeatedly every day. So even if it saves only, let's say, 10 seconds or so per item, I think it adds up. The screenshot here shows the GUI, which I will show in a second. So it's only a 15-minute presentation, so hopefully I'll won't waffle on too much. But yeah, the first these are the contents. First, I'm gonna kind of demonstrate how we go about creating new VIs. Well, I'm not sure we all know this, but just to show kind of the workflow without the tool, then I'll show it with the tool, and I hope that will show that it saves a few seconds. And then some further improvements that I'm aware of already that I kind of have in my mind that I would plan to do over the next few weeks. How to install it and the fact that it's available on VIPM. And just more resources for developing more of these plugins. So if I now jump out of the presentation and go to a dummy QMH project that I have here, if I just launch this project, I'm using LabVIEW 2021 community edition here. But let's say I was working inside of this library. By the way, just to mention, this project is just a vanilla project created from the QMH template. Go to the sample projects in LabVIEW. So it's just a plain vanilla QMH project, just to serve as an example. So let's say we are working inside of an LVLab library. Let's say we're editing this particular VI. And we realize that we now need, let's say, a sub-VI inside of this VI. You usually have two options. You can select things and then go to edit and then go create sub-VI. Personally, I almost never use this option because I just prefer creating my VIs from a template that already has maybe the error, like an error case structure and error terminals the way I want them to look and things like that. So if I were to do that, now I would have to go on to just use a Windows File Explorer, maybe navigate to the location where I have my template, or to physically copy that file, paste it into my project, then go into the project and right-click on my library. Let's say I want to add a subject to the same library. I would go Add File, and then I would point it to the file that I physically put into my project a second ago. So that's that's very doable. It's not too bad, but I think this can actually take some time. And I was thinking, why can't we have a tool that more seamlessly can achieve this without breaking the workflow so much? So this tool can now do something like this. So when I'm inside of a VI, in order to bring up the tool, you need to right click on a free label, a comment. So let's say this one here. Can be any free label as long as it's on the block diagram. And then you have this option here, new VI from template. So when you click that, you get this sort of GUI. And what it does is it looks in a particular folder on disk where you can keep all your templates, so all your VIs and all your control templates. And then you can click on them like this. And it loads the block diagram here in the bottom panel as a preview, just for you to kind of see which one it is. If it's a control, obviously it doesn't have a block diagram, so it doesn't load anything. And once you're happy with it, let's say I'm happy, I want to create a new VI based on this template. I have options such as adding it to the library that I was in when I right-clicked on where I was. So I have that option, which I believe is ticked by default. Also, it tells me here the destination, which by default is going to be in the same folder as the VI I was in when I right-clicked, because often you kind of want to put VIs in kind of the same place where you were, but you can change that by clicking on there. If you don't want to add it to the library, but just to the project, you can click there, and then you have an option of perhaps you have multiple projects loaded at this time. And you can choose from there. And also you can choose to open the front panel automatically once it's created that. So let's say I want to add it to the LV lib and open the front panel. So if I do that, it created this VI, which is a copy of one of the templates that I happen to use. I personally like having a template that has this sort of decoration on the front, because now I can put different controls in these three different kind of sections. So controls that I expose to the user as an input to the VI, I will put them on this side. Then indicators that would be exposed as an output will be put on that side. But often you also need maybe some indicators just for developing and testing, some kind of internal indicators that you don't want to expose as outputs. So for those, I will put them in here in this development section as well. So now that I have this template, you can see it's here. It also has this little comment here that I kind of like to have there for all my VIs. And when I remember, I do type some meaningful comments there, but sometimes I don't. Okay. And now we can close this, and we can see in the project that it's been added here. And it's been added with the same name as the actual template file. So now typically I would press F2 to rename. I would rename it to something like scope initial, let's say. Yeah, and now let's say I was working back in the main, which is not in a library. You can see the main is outside of any library. So if I'm here, and I again right-click on a comment, I have the option. And now I cannot add it to the library or class because where I clicked from is not part of the library, but I can still add it to the project. Let's say I want to add this different template VI. I do create, and it's here as well. Yeah, so it's a very simple tool, but I find myself using it daily. And also, I want to show that it's very easy to add more templates to that particular location. So it's quite expandable and customizable in that way. So the tool is installed in the default location for shortcut menu plugins, which is in the library folder. It's under resource. Plugins, pop-up menus, edit time panel and diagram. And the plugin is this one, the new VI from template, LLB. It has to be an LLB. That's part of the kind of design from McNally. You can see I have quite a lot of them here because I've installed over time. I've installed from other community available libraries, which I think are brilliant. And the template VIs are here, template VIs and controls. So they're here. So if I were to put another VI there, let's say I think my scope initialize is actually pretty good, pretty I might want to reuse that kind of design, then I might copy it from. Let's see, copy it from where it is. So, I don't want to listen to music. So if I copy it from here, now I probably want to remove it from library first, because it is part of the library. I don't know if that's. I removed it from a library. Now, so if I go back to scope initialize and copy it into the templates folder. So let's say this is my 5th template VI. I number them like that, 1, 2, 3, 4, 5, such that they always appear in the same order that I find. I ordered them in the order that I use them the most, so the most common one is at the top. Obviously, they can be ordered alphabetically, but that meant that the most useful one would be at the bottom sometimes. So, yeah. So now that it's there, we can go back into. Let's rename this maybe to. Something else so that it doesn't clash in terms of names. And what happened? I think I stopped working. Maybe battery is person, so I'll use the trackpad. So if I go into main and now run the tool again, we should see that 5th one appearing. Yes, and it does appear. Don't know why it's not at the bottom. I would have expected it because it begins with 5. Oh no, yes, it's not at the bottom because it lists the VIs first as a category. So you have 3 VIs first, and then the controls and typers. Yes. So it's there, so we can create copies of it more quickly if that is needed. Yes. So pretty much in a nutshell, that's what it does. I'm aware I have 5 minutes left or so.
No rush, no rush.
So. Okay, so I showed without the tool and with the tool. Further improvements is as I developed the tool on my desktop computer, which has a regular 1920 by 1080 screen. But when I tested it yesterday on my laptop to prepare for this, I realized that by default my laptop was using 125% scaling in Windows settings, and when that happens, the GUI is actually slightly too tall to fit on the screen. You can move it around, but still, it's a bit annoying. So I think I need to maybe reduce its vertical size a little bit by maybe 100 or 200 pixels, and then it will fit on most laptop screens, which I think by default have 125% scaling. Yeah, so that's one improvement. The other improvement is it would be nice to preview the front panel as well. In another sub-panel on the GUI, not just the block diagram. And I think that's very easy to do. I don't know why we didn't do it to begin with, but yeah. Also, it would be nice to be able to rename the new VI that's going to be about to be created from the tool itself, rather than what happens currently, which is it gets added to the project or the library, and then you have to rename it from there. It would be nice to be able to insert the VI or controller directly into a particular virtual folder of a library where you might be working, rather than just the library. So at the moment, if you're working in a particular, if you're triggering the action from a VI that's in a particular virtual folder, the new VI gets added to the library, but not to the particular virtual folder where you were in. So that might be a small improvement, and maybe with a tick box on the GUI that could be selected. So, also, it would be nice to support VIT and CTT files as templates. Personally, I don't use them that much. That's why I probably didn't include them from the beginning. But of course, they should be supported. I think. Also, it would be nice for the icon to automatically apply the import icon from only library option. I played around a bit with the VI icon API, and it can do lots of stuff, but this, I don't think there's a particular API that can do exactly this. So at the moment, normally I have to, once I create a new VI into a library, first thing I do is I double click on its icon, and I go to edit, and then select import icon, such that its banner takes from the library. But that would be nice to be done automatically. There's a small bug I detected, which is if you have a VI with the name of one of the templates in your project, but then you want to add another copy in one of your libraries, it brings up this error 56003. Now, I don't know why LabVIEW does that, because it shouldn't, because obviously then the library namespace is the VI, so you should be able to add it there. But I think because it first maybe tries to add it to the project and then to the library, maybe it errors out at that first step because there's a clash. But I need to look more into that. Also, it would be nice to have maybe a settings menu. So maybe on the menu bar, there could be a settings where you could change the location from which the templates are stored. I imagine actually this is a very key feature that I will be looking to add in the next few weeks or months. And yeah, I think that's everything. Yeah, you can install it using VIPM. It's on an MIT license, so it's completely free to use. It's also open source, and the source code is at the GitHub location there. And some more resources for developing shortcut plugins. The way I kind of learned about this thing and kind of got excited about being able to do this. There's an NI community, an excellent NI community kind of group for all of this, which is linked there. And when you access that, the right at the top, there's a quick links section that I think has been created by Darren Nattinger or Stephen Lovelace Mercer. But anyway, they did a great job, and there's a bunch of very useful getting started links there that kind of explain how these plugins work, what you need to do to get started, to create your own, and so on. Also Darren and Stephen have created 2 posts in that community group where they list their own favorite shortcut menus that were created by a bunch of other people or by themselves. But I definitely found some really great shortcut menus from looking at those lists. And also I created a few months ago, I created 2 lists or 2 posts in that group where I listed every single one of the libraries that were posted on the community over the last few years. They weren't grouped in one place anywhere. So you could see the favorites from Darren and but you couldn't see all of them in one place. So I created a list that lists all of them. Had to split it into 2 because there's a maximum number of characters in the NI community total, but yeah. And currently there's 99 community-made plugins on those pages. And that's everything. And if you've got any questions, I'd be happy to answer if I can.
You configure it so you can right click on, as well as comments, you can also right click and say,
Absolutely. That can be configured. So the reason I selected this action to trigger this gesture, I realize it's a bit arbitrary. It's just something I had to select something to right click on, and I thought, well, a free label is quite neutral, so I wanted to be quite neutral. So yes, that could be you could make the plugin a trigger on a variety of objects, or you can even make it happen only when a certain combination of objects is selected. For example, you might select a free label and then hold down Shift to select another, let's say, numeric constant. And then when you right click, LabVIEW will figure out, okay, you've got these types of objects, and now I'm going to show these options because you told me to play that. So
you can't make it big when you just click the drop down there.
No, you can't make it do that. That's an intentional limitation from, I think, because that would lead to potential security things, but yeah. So the functions palette is always the one that comes up when you click on an empty place in the web list. And potentially maybe a better trigger for this action would be a menu, a menu selection in the menu bar of LabVIEW potentially. So maybe I could look into that. But for me, this works. I kind of got used to just right clicking on free label, which they're always around, I find. And if it isn't, I just double click, quickly type ABC or something random, then right click on that and get to this.
Do it off quick drop would feel quite natural to me. Do it as a quick drop one. It's cool. It's weird how complicated such a simple thing becomes.
I was even thinking of maybe having a quick drop gesture, but calling into the same common code. So you have both a right click and a quick drop action calling the same libraries. And I'm sure it's possible, but maybe it's a bit more work. Thank you.
That's great. Thank you. I had a quick check about max settings for this, and it is set up how it recommends, but also I haven't got anything revolutionary different from that. I think it might be working. Uh-huh. So thank you. Oh no.
Okay, I'm going to just like present something that I was going to present at my GDevCon talk. I just show hands. Who was at GDevCon? Okay, so following the talk, I was trying to do principles of UI. And the principle I wanted to use here is something called a window. So this is a logging tool I had for about 10 years. I use it like every project. It has an API which allows me to log messages, and then as a viewer, which allows me to look at the log. Anyway, so it's a log file, and it's got a lot of functionality in it. So you've got like, warnings and errors and different levels. This is on debug level, and you can turn down to standard and reduce the number of things you're looking at. And it has a lot of capability, like I can type in and look at things that are like test. And I can highlight the things that show up in blue, or I can just look at the few entries that match that pattern. And I can switch between the things very quickly. And normally I ask people at this point, this is a it's a table. Normally, if you do a UI work and you want to have lots of this stuff, you have to go to property nodes. You got to like color it around. So this has 8,000 entries. I can get a bigger one, get a bigger file. Takes a little load, but this one has, if you look at this one has 7 million entries, and I can scroll down it very quickly. Okay, now this is generated just by a very simple loop going as fast as possible. But I asked, how can you do a file and have a huge table of millions of entries with all these different colorations and stuff? So I asked, how do I do that? Anyone?
Limited number.
So if you look at this, if I were just to kill this and open this up, the scroll bar isn't part of the actual thing. So when you're ever looking at this, it looks like it's a giant list, but really you're just looking at this one little bit. This is what I call like a window, in that I'm not getting all my data from the file, millions of entries, processing it and making a massive thing that would be incredibly slow. I'm just saying I only want from entry 1 to 30 from the log file, process just those 30 rows, which means that 30 rows I can do as much as I want in terms of UI stuff, because it's 30 rows. 300,000 you can't, but 30 rows you can. So that's the idea of a window. And it also illustrates some of the things I was doing in my talk about control model view, in that I'm kind of viewing into the model. In this case, the actual data file, which is an SQL database, is the model. There's one copy, and I'm just grabbing what I want from it. And it allows me to add a lot of functionality, a lot of display functionality. Like, for example, if I click on something, I get, what I want to go through is that, from log files is, I do a lot of time looking through log files, trying to figure out what went wrong. It's actually really hard to debug log, to figure out what's going on from the logs. And so things like clicking on thing and seeing the relative times helps a lot, because you can tell if things happen close together or if they were far apart. And the coloration things of like errors and warnings and different levels also helps. And you can add functionality very quickly, because all you've got to do is get the stuff you want from the log file, process it, display it. If you change anything, you just do it again. So it's actually, once you've got that one bit, get stuff process display, it's done. There's not a lot of like stale cache problems or bugs in terms of the display because you're just doing one quite simple thing. You know, you want to change something or add something, there's only one place to do it. So just to show a little more, so this is actually the first project I ever did SQLite with. And it shows like, so that this you can use SQL with SQLite. So here I'm selecting the information, I got all the information. This builds up a statement that has my filter. So I have conditions like the main text is like, that's where I type in words to have it search for that. And the various things that add up to build up one select statement, which I just run. And whenever anything changes, including just moving the scroll. So it's actually quite quick for reasonable file sizes. So when I'm actually drawing the scroll bar, I'm just again and again doing the whole thing from scratch. And so it's actually quite powerful and capable technique. Kind of shows a lot of the principles that I think are important. It's hard to say though. So anyway, any questions? Just trying quickly. This is available actually. This is the latest version. I've put a lot of improvements on lately. But this will go on the tools, on the tools now, on the BIPM IO. So the older versions have been on there for ages.
The relative time is really smart. I've never seen that before.
That helps a lot actually, because I spent for ages like,
yeah, do the math, yeah.
Click on things, yeah. Also, I like is with this little new functionality is if I want to say the one I'm calling, they want to go through all the serious errors, and then when they want to click on one, say what's that one? Often you're like, well, what happened around that? You're interested in that's the problem, but what happened around that? Tell me about the problem. Yeah. And so by doing that, I can change to debug, and it pops up around that log entry. So before it would just go to a new list, and now it pops up around it, so I can look. Well, 40 seconds before this happened, and 39 seconds after, I can actually tell what's going on at the same time. And when I'm finished with that, I can go back to serious and then find another one. See what happened around that one. And then it expands around that, so you can see what's going on.
What does the API look like?
For writing messages?
Yeah, for writing messages and making setting the colors and the like debug serious. And...
Yeah, so it looks like this. So you basically create your log file. Display name is you say this guy is called the tester. So you can have more than one thing going that have different names. You can even have more than one exe all sending to the same log file with different names. So you can like have multiple things going on. And then the actual logs are mostly just, yeah, for example, there's a double. So again, the simplest thing is just you just slot some text with a trace name.
So what's the scope of the display name there? As in?
So I use one of these things where they have different like DQMH messenger library, where you have differently launched things. Each one is a different top level VI. So it uses the top level VI to identify
Okay.
things, right?
So if you put that in another sub VI,
So
it would just.
if you put a sub VI, it'll be the same. So everything from the same hierarchy is logged as the same thing. But if you have different components, so if I go back to show this one, this is an actual client. So they have different components that you can show up.
Yeah.
For you look at everything.
They have to be launched as a top level VI.
Yeah, so if you're dynamically launching it, if you dynamically call it, that's a top level VI. That's what we'll show. And so it allows you to have different modules. You can also, and as I said, you can also have different EXEs that both record the same file. Of course, you give them different names and they show up different.
Yeah.
James, it looks great. Yeah. It reminds me a bit of the filtering and highlighting you can do in the process monitor tool from Microsoft System Terminals.
Yeah.
It's a tool. It's a freely available tool that you can use to investigate crashes, Windows crashes, or app crashes on Windows, and so on. And it shows very fine-grained list of events that happen in Windows, like all sorts of API calls and so on. And it reminds me of that in the way in which you can filter and almost like zoom in to a particular issue.
Yeah, so if I can think of something, I don't know. error. It very quickly pulls down to what you want. 1, 2, 3, that show up anyway. And it's really quick, so you can do that. Also, I like to show if you go to 1, 2, 3, and you go highlight, it pops around, so it highlights those things. And again, you can actually look at what happens around it. So it's not just find the one thing, you've got to know what's going on at the same time to really diagnose what a problem is. So to be able to jump between, find the thing I want, and then look around it is what I'm trying to achieve with the latest changes to this. Because as I said, trying to figure out what went wrong when the log file is often really, really difficult. Quite often you find that you haven't logged the most important piece of information.
Yeah.
And you've logged a bunch of irrelevant information at the same time, which really confuses you. I'm trying to improve that.
James, does that, for the API, does that have something that takes an error directly?
Yeah, so I have a login error. Let me just see if I can run the timer.
The error cluster looks like it's not an error type.
I've done something stupid. I moved it. Okay, so if I start this, I'll ask for a thing to start going. Another thing is this is useful online, so it'll actually, if I start making some messages, they'll actually show up as you go along. So you can use this as an online tool while you're doing stuff. You see log entries come in. So basically, just if it's at the bottom, it just keeps scrolling as new entries come in. And then using errors. You can log thousands and thousands of entries per second. Things like if you want to do your own, have the user be able to enter their own, the user can enter log entries as well. So it's designed relatively easy. You just drop, you have to say start the log, say what the name is, and then anywhere you can just drop the VI to log whatever you want. Log the log numbers and log strings and errors. And, so yeah, I've used that for like 10 years. And it's useful to just have, anyway, it's useful to have a logger you just trust and just throw in your project. We got this.
Yeah, I've had a text one that I've used for quite a long time. Like you need to play with SQLite for it. Now I don't think I've got anything. I might just rip yours off.
Yeah.
That view is really nice.
So yeah, 31. So you can really highlight things and find things quickly moving out. If you look at the whole log of everything, it's just too much. Yeah. Really hard to figure out what's going on.
Is the source code available for this, or is it just as a library?
But you can look at it. If you install CSLUG, again, wait for a bit for the latest version, then you can actually find all the code. Password protected everything. When you do logger itself, I did it at a time when I was learning actor framework command pattern. So I did it in that way, which is actually a bit difficult to understand.
Okay, thank you very much.
Cracking, right. Hopefully everyone online has spotted we're on again. I am still recording. Yes. So you're good to go, Mike.
Cool. So I think I actually know pretty much everybody in the room. I'm Mike Bailey, I'm a software engineer here at Agilent. I've been here for 8 years. I was previously with Cobalt and before that NI. Ancient history. So I'm going to talk to you today about LabVIEW and pipes. It's a communication method that I've dabbled with in the past. Did it at CLA Summit and someone said, why don't you use the .NET thing? I'm like, what? The what? I've spent 3 months getting this to work and you mentioned this other way of doing it. So I'm just going to talk about this a little bit. So LabVIEW's got all sorts of communication methods built in, queues, events, notifiers. We use them all. And they work really well if you want to talk between instances of LabVIEW. but they fall over if you need to communicate with other languages. And many of us are starting to use other languages or have been doing it for a while. Or if you're trying to talk between LabVIEW instances. So if you're talking to LabVIEW on the test stand from a controlling LabVIEW, that doesn't work so well because they're different runtime engines. So you then go back to the old things of TCP, UDP, RESTful if you're into web services, but they're open to the rest of the world. You've left an open port or an open socket somewhere, and security is properly hard. Now, we kind of deal with this all the time. We leave our applications open to users, and they're lovely people who find all sorts of ways and holes through everything. Because we make sure that water bottles and things like that that go onto the planes are safe, and we check for chemicals in sealed, unopened, unknown containers, we get a lot of questions from a lot of people on how secure our systems are to make sure that we don't get hacked. So we need a better way, and we start talking about things like certificates, and then I need to make sure my certificates are signed, but I'm on an air gap network, so I can't reach a signing authority, and it's horrible. It's absolutely horrible. So we need a better way. And pipes, whilst they're not perfect, are certainly a better way. So you can almost think of it like a queue within LabVIEW. So they're bidirectional, so I can send information both ways. They are inter and intra process, so I can send it between processes or just in the same process. They're secured. There's a variety of ways of securing them, so I can say how many people have access to it. Is it available from outside of the machine? Who has access to it based on the username on the PC? So definitely limitable in that respect. It's all done through relatively simple .NET, and you can have them as synchronous or asynchronous processes. So you can just start piling data in there, and then the other end will pull it out at some point. And you either care or you don't for the synchronous or asynchronous. So there's quite a lot going on. If I show you a very simple demo, very simple. So massively complex. I have a server. I'm going to double click that. So get that running. And if I just click run on this, it sends hello. This gets, the server gets hello, and it sends I got hello back. So it's just very basic. What have you sent me? Change this. I'm going to get this information. And it just keeps going and going for as long as we want. It's kind of like a TCP. You'd have this going, but this is limited to only 2 users. So if I have a constant client connection, I cannot have another constant client connection to it. It will be locked out. So I've set this as 2 instances. So the code. So I've wrapped this into classes. It's really not great resolution to see this at. But here I'm setting how many instances that I want it to work with. I've got a name for it, so it's done by a name reference. There is an actual reference. And then I've opened the server connection here. Ignore this bottom section for the minute. So I'm just going to wait for a connection. When I get that, I'm going to read a certain number of bytes. Based on that, I'm either going to respond or stop. I'm going to write something back, disconnect, and then go back round and wait. Now, there isn't a simple LabVIEW way of stopping these. So what you do within .NET is you actually wait on multiple interrupts. One would be an interrupt from the pipe saying, you've got something, and the other one is the thing that you would say, I want you to stop. That's kind of hard to do in LabVIEW. So what I've done at the bottom is created my own client where I send the, if you press the stop button, I send the @stop out, which is this is looking for just to quit. So I'm utilizing one of my clients here anyway. Hence I've got it set to 2. So I've got one is an internal client to stop it, and the other one is whatever I wanted to talk to. And the client, it's ever so complicated. There's a timeout. So if I don't get any response or any connection, there isn't a connection available, I'll stop. I want to connect to HW. I'm going to open this. So this is a client open. Send the string, read any response, and close it. So it's just a simple burst of communication. But I've got that two-way. I'm using it bidirectionally. Send a command, and it can send something back. So all of this is .NET. So I can open it. So I'm just using pipe name. You can set up if it's going to be whether it's going to be bidirectional, is it asynchronous? You can set up to actually a remote system as well. So you can have this between PCs, but that depends on the name that you've given it. So I have to give it a server name here as well. I've kept the scope of this down to 1 PC because that's all I want. I would use TCP to communicate between my 2 things, but here I can swap that for the client, for the pipe communication, so I don't need to worry about security. Yeah, so you've got pipe access rights. So I've just started playing with this. I'm not. Well, so you can set it so that only a user of that machine who is logged in has access to the pipe. So that means that anybody else who tries can't have access. You can actually specify that it has to be a member of a particular group within there, but you're starting to go very far into the Windows security IDs, and it gets more complicated. So a simple demo for simple purposes. So there is a hell of a lot that you can do. So you can do token impersonation as well. So you pretend that you're the person at the other end who is connecting must be an admin, and I must pass this token over to them for them to even connect. So it can get even more secure than that. But the actual reads and writes, so the read, I've just said, just as you would with TCP, a fixed number of characters tells me how long the string to read, and then read. That's it. And the write, conversely, takes the length, encodes it into the 8 character length, gets the reference, and writes it. So there is a lot of scope here. There are specially named pipes that you can get hold of for things like standard in and standard out. So you can do stuff with those as well. But again, try to keep the scope fairly limited and not push this out too far. But we certainly have applications for this talking between different processes that we've got going on. Then, any questions? It's true, that.
So the kind of, I'm trying to compare this to TCP in my head and understand the server pipe kind of model. So the server opens a pipe which exists on its own.
Yeah.
While a client is connected,
The
no one
client
else
can then connect, yes, but you can set how many you
so you
want.
can have multiple
You
clients
can
connected.
have multiple clients connected. So because of the application that I've got for this, I've limited it to, you can have up to 255, which should be plenty.
Yeah.
So once that pipe open, it's like opening to its code.
Yep. Well, it's not particularly complicated, but
When you have two clients connected to the pipe,
Yeah.
both want to find. What's the, which one has priority?
If the first come first served, they will just queue the data into. It is in that respect, it's like a queue. You can have multiple entries in there.
And you sort of lock for clients to just read instead of write stuff.
Yes, I think.
Is there a list of what would be?
No, I think you need to set it to bi-direction. You may be set from the server end. But as you can see, this is just the client end of the stream. There's quite a lot you can do here. So you can flush it so you can get rid of anything that's actually in there. You can wait for it to be empty. But then you start getting into registering with callbacks and stuff like that. Again, lots and lots of possibilities.
I think someone really enjoyed writing the wait for pipe drain function. Someone that had a smile on their face when they wrote that.
Oh, this is way faster. Yeah. Yeah, I know when I wrote it previously in a horrible fashion, I was getting a couple of 100 megabytes a second through, and that wasn't using the .NET. That was several layers of dirty DLLs.
I'm sorry. Okay.
Does it depend on .NET framework, or can it work with .NET Core and .NET 5 and 6? So like,
I believe it's .NET Framework, but it may well be in the core because it has been around for a long, long time. So when you put something in the command line and you put the bar in, that's a pipe. So you're piping something from the standard out of something to the standard in of the next thing. It's still a pipe.
which is very common in PowerShell scripting.
Yeah.
Nice. This probably relates to your question as well then. So each client, do you end up with a unique connection? You like using TCP balance. So if you write from the server, does every client see that? Or do you choose which client will respond to?
I think every client. I've not tried multiple clients. But yeah, that would be probably set that up.
Yeah. Okay.
Try.
Is it literally just by name? So if you had two separate PCs and you just had pipe, and then this one pipe as well, and server client, and they would just go to.
So when you get to sorry. So instead of the dot here, you would actually have the PC name.
Oh, okay.
So it then identifies it as the pipe that's on that one. But then you have to set something at the server end, I believe, to say, I want this open to client. Multi-PC clients.
There are a way to see all pipes that are open because you don't want to end up with a name that's somebody else's name. Right?
Yes, there are. There's a command line function for it. I can't remember.
So you've got a way. You need to almost have like a GUID or something for your pipe, right? That you don't end up accidentally writing.
Yes, but then you've got to make sure that you also know that at the other end, which kind of makes your security
unique.
Yes.
Yeah.
When the pipe is used between two different computers, presumably TCP or UDP is used.
Yeah,
at the
but
lower
you
level.
don't know /care at that point. That takes it, it abstracts it away again.
It's considered to be more secure than doing TCP ourselves.
Yes. Yeah.
Exactly, because you're abstracted away from the security.
Yeah, but your Windows steps in at that point. And yes, you've got to deal with Windows security, but certainly from my perspective, lots of the other questions that people then ask you go away. Because they go, oh, okay, that's fine. You're using Windows security. That's not a problem. As opposed to trying to, it's like when you put a password in the database. Well, how have you stored it? What have you done? Do you unencrypt it to check it? And you go, oh no, we're using Active Directory. And they go, oh, okay, that's fine. All of those questions go away. And it's just being that. Okay. Thank you very much.
Tripping over it. So I am going to preface this, but this is rough. This is some ideas floating around, and I'm kind of curious to see how it translates to LabVIEW. And so I'm kind of intrigued to see what's interesting to people, if it is interesting to people, because I want to do something for the GLA Summit maybe. I've applied for presentation topics around this. So let me get it fired up. Oh, I should have started this sooner. So a bit of background to this. I have been doing some relatively high performance analysis work in C and in Rust. And so I've been learning a little bit more about processors basically, and trying to appreciate how the design of those and the management of those impacts the performance of what you're doing. And essentially what I want to do is take those ideas across to LabVIEW. Some of these will hopefully feel relevant. Some of them will probably feel like, why on earth do you care at that level? But sometimes you do. And so really what I've got is a bunch of demos. Tweak the resolution. Where I was playing with a few early ideas of what kind of matters in LabVIEW and what's kind of interesting in LabVIEW. So I'll start this by saying most of this is going to matter when you have a big chunk of data. So in my original case, what I'm kind of interested in this, we were dealing with 1 megabyte images. Scales up, so I've got a customer using 50 megapixel cameras, and you know they're not achieving those kind of frame rates, but some of these factors are going to start becoming important in how they run their analysis. So LabVIEW is okay for this. Is how I would describe it. In this application, we tried to do as much as possible in LabVIEW, and we got a hell of a long way there. So I'm going a little bit by memory here. We wanted to get to about 1600 frames per second when I started this project. The code originally did about 150. Just in LabVIEW, we got to about 800 to 1000, which is pretty good. But at some point, the memory management kind of gets, and I just trying to do two things at once. in LabVIEW, you get less explicit control over that, and that can be the challenge with LabVIEW. But a lot of things are common as well, and that's kind of what I wanted to explore with this. And so this focuses mostly on kind of memory structures. I'm also kind of intrigued by some of the basic optimizations that LabVIEW has as well. So who has a sense of what a processor memory cache is? One or two. Cool. So this is the kind of basis of some of this. So processors have done an awful lot to get very fast. And what we really want to do is work with that. Because if you fight against it, it's when you tend to end up finding you have something that's running freakishly slow compared to what you thought. And there's a bunch of stuff that the processors do that I won't even claim to fully understand to do that. But one of the interesting ones when it comes to dealing with large data sets is memory layout and memory caching. So on a modern Intel processor, you have 3 layers of cache. And essentially, these sit between the processor and the memory to try and keep frequently accessed memory in faster data. So they always talk about ratios, and I forget the exact numbers, but I think it's something like the level 1 cache, which is the first cache, is the smallest by a long way. I think on my system it's something like 64 kilobytes per core. So very small, but very fast. It can actually work in lockstep with the processor. Then on Intel CPUs, you have a level 2 cache. So this is bigger. On mine, I think it's about 1.5. I've got all of these in here somewhere. One of the VIs. It's about 1.5 megabytes per core. And it's something like 20 times slower. I don't know, maybe that was 5, and then level 3 is 20 times slower. So that's bigger, and most importantly, that's now shared between all the cores. So if you've got a 4-core system, that level 3 cache is bigger, but all the cores get access to that same piece of cache. And then if what you're after is in none of those, you go all the way out to the main RAM. So that's your 4 gig, 6 gig, 8 gig, whatever your headline figure is. But that's something like 200 times slower than the first level cache. So, like I say, if you're dealing with small bits of data, like a kilobyte, it kind of doesn't matter because it all fits in that first cache anyway. But once you're starting to deal with arrays that are measured in megabytes, certainly, then the way you access those might matter. I want to show you kind of a few of those cases. Did get all of there we go. So yeah, so this is the processor spec of this machine. So this L1 cache is 80 kilobytes. Then the L2 cache is 1.25 minutes. So new is around about that. And that's the per core. So what this VI does, these are a little rough, and then there's a lot of save as, which is why the size seems a bit off. But I'm going to make a bunch of square arrays based on these sizes. I've got to try and beat the processor from being clever. So what I'm doing here is for each of these, I'm generating some random points in the array that we want to access. And then we're just going to do that. I forgot to put this time structure in. This didn't really make a difference. A time structure forces everything onto one thread, and I was kind of intrigued to see whether that had any impact. All we're doing here is we're indexing out elements, and then I keep them and sum them. This is just to stop LabVIEW optimizing this code away. So if I don't do anything with the data I'm accessing, it'll just get rid of it because there's no point in having it. And these numbers seem very small, but this is about if you're having to do this a lot, they really add up. So I've been tweaking these to try and take a handful of seconds, which is going to feel twice as long for all of you. But it gives enough time for the processor to kind of spin up to whatever clock speed it wants. And if there's background stuff interfering, it helps with that. These kind of micro benchmarks are super liable to being biased by what else is going on. So don't set the absolute numbers. as golden fact. But hopefully what we're going to see here is as the size goes up, the time to access an element increases quite quickly. And we should see some specific steps. Now, in this code in LabVIEW, I can't see the step from the level 1 to the level 2 cache. And I haven't worked out why that is basically. Maybe it's just too insignificant in the way of accessing it. But if you see my level 2 cache comes in, where are we, about 1.25 megabytes. And that's where this starts scaling up because more and more of the accesses are now missing, it's called a cache miss, missing the L2 cache and having to go to either the L3 cache or the main memory. And I mean, this is quite significant. What's this, about 4 or 5 times difference by the time we get to the end of here? And if I had a lot longer, you can run it fast enough to see where it starts hitting DRAM instead. And then it's really slow, relatively speaking. When I say really slow, we're talking about nanoseconds here. It's all about when you've got that's big enough that matters. So that's the basics. And you see this quite interestingly in the first time I saw someone try and do something like this LabVIEW was with notifiers. I actually think it might have been the performance course. It's just come back to me now. And you can see the same things. They're pushing data through notifiers. As the size of that data gets bigger, you can see the step changes as it goes through the different cache levels. And as you can imagine, that becomes all the more complicated now if you're going between cores. So it doesn't matter if it's in L2 cache here, the other core can't access it. So that also gets interesting. So let me give you something that's probably a little bit more relevant to something we do a lot. And that is pulling data out of 2D arrays. So this is where I mostly came across this course. An image is a 2D array. The other place I see code a bit like this a lot is with DAC. So maybe at DAC and XFeed you don't worry so much, but maybe if you're working with scopes, for example, you're going to end up with some pretty big arrays. So here I've got 4 different tests. I've changed the order around because I was trying to figure out if there's a bit of a bias one way or the other. The first test, you'll see in the next one, actually, I end up having to do loads of tests first and ignore them because it takes time for everything to kind of get going. But here we've got a 2D data array. Again, we're going to randomly decide, let's call it which channel or which sample that we want out of our 2D array. And then we're using the 2D array functions to index out an entire row or an entire column. And then how many people do this on a very regular basis? I know I do. Oh, that's not the way I wanted it to be. I'll stick a transpose in. Now, transpose is clever because this doesn't copy the memory. This just creates what's called a subarray internally in LabVIEW, which says treat this access as if it's the other way around. So does anyone have a feeling about what might be fastest here, or will there be any difference or any sense?
General stuff. I've applied new columns in the last year that switch to rows and actually 1/3 of their processing time.
Yeah. So the way that LabVIEW and most languages store 2D arrays, it is actually the right phrasing. It's a 1D array in memory. It's one long strip of data. And you do row 0 first, and you do row 1 next, and you do row 2 next. And then when you access it as a 2D piece of data, it's kind of calculating how to jump through that data. So what happens is when we go through it as a row to pull out the data, that one is faster than I expected. Yeah, see that top one is almost certainly, oh no, it isn't wrong, ignore me. I wanted to come out right. When we're going through pulling out a row, we're looking at a load of sequential memory. Now, what the processor does is it assumes if you wanted memory address 1, you're probably going to want memory address 2 next. So it'll pull that into the cache as well to help speed it up, as opposed to randomly jumping through memory. So when we access things by row, we get a much faster time than when we access things by column. In this case, 5 times difference. This time is also measuring the time it's taken to build the output. So this isn't just the access itself, but more as a relative measure. So transpose makes it really nice and easy to flip that ourselves, but actually you'll see that that's transpose and accessing the row. All that happens is the performance flips as well. So on some APIs, and I've not measured quite what they do internally, so measure it yourself and see how it goes. If rather than using transpose, you may get better performance if you tell the API to return it in the opposite method. So I think there is a way, pretty sure there is a way to do that on DAC-MX. There certainly is in TDMS. So if you're going to access it the wrong way, lots of times, actually getting it in the right format in the first place is really important. And this seems quite inconsequential at this level. But for example, SQL databases and NoSQL databases are almost like a bigger version of this. SQL databases are really biased to pulling stuff out row by row. There's a whole series of NoSQL databases which are designed by column. And really all they do is to store the data differently to take advantage of this effect, but on a hard drive level rather than a PC level. So one more thing to show you. This one didn't really help. So another place where you might see a decent change for this is in how you arrange the data in structure in clusters of arrays or arrays of clusters. So this can make a vast difference to performance, again, depending on how you want to access this data. So here I've got 3 clusters, different sizes. And I'll explain the meaning of the sizes in a minute, but they don't make a huge difference, right? And then I have a cluster of arrays. So again, this is about how I want to read that data. If you think of each cluster as a row, if I want to read out each cluster, then a cluster of arrays is generally going to be faster because all that data for the cluster is going to be stored next to each other. We have one piece of memory that we're accessing. So in this case, what I actually want though is I want to pull out the columns. So for each cluster, I'm reading out one of the values of cluster for every element of the array. And the cluster of arrays, they just have to read out one array. And so that is how much faster I remember. So this is the one. I have to do a bunch to kind of warm it up. Otherwise, the first ones are much slower. I should have started that before I started talking, pretty sure. See what it is. So I'll explain the purposes of this as well while waiting for that. I can't remember if it shows in this test or the next one. The data caches on Intel processors. Oh, that's quicker. I'll come back to that. So here what we see is our clusters, our 2 larger clusters, about 53 microseconds. Our 24-byte cluster, so a smaller cluster, is slightly faster. And this is to do with getting it into the cache. So the cache is created in blocks of 64 bytes. They're called cache lines. So that's the significance of these numbers. So you can actually get a couple of these in a single cache line. So it's having to make less fetches back to the memory to pull that out versus these larger ones. You know, this one, you're always going to have to jump a couple ahead through the cache to get to the next one. But this effect is small here because the processor is already guessing you want the next line anyway. The cluster of arrays in this case is much, much faster. And it's really exactly the same thing as we saw with the 2D arrays. With this cluster of arrays, we're fetching out a sequential bit of data. Whereas with these, we're having to jump through memory to find the elements that we're actually interested in.
I feel like you had a question from one of the teams.
Oh, sorry, yeah, I should have wanted to answer. Have you got it?
I think it was in another Teams thing because there's nothing in the CSLUG.
No. No. Normally pings from here as well.
I think you're good. Oh, people waiting in the lobby, that's why.
yeah, I need to work out. I thought I set it up as a webinar this time, and I thought it would disable that, but it did not. Baby steps. Yeah, that's what it was. Last one. So I'm going to pull up the last one, which is kind of the reverse of this. So this time instead, I was playing with, well, what if we do random access through these arrays instead? And really what we see is, I've already written it here, so I remember. The difference becomes a lot smaller because it's not able to predict the cache anyway. We're generally beating the cache and having to go out to further cache levels. So the difference between the different clusters is becoming smaller. I mean, generally it's the, should that be faster? Oh yeah, because in this case I'm only pulling out a couple of elements, I'm not pulling out a whole array. So that's good. But yeah, so that's what I had. I was kind of playing with how much of an impact does this have in LabVIEW? As I say, really what we care about here is when you've got big data arrays, it's worth thinking about how you kind of access that. And if you do any searching for memory access patterns or memory structure performance, you will find a wealth of information from other languages, which does generally translate to LabVIEW. You know, there are impacts that are measurable in LabVIEW, especially over larger sets. Yeah.
You mentioned a lot, like you've done your testing with Intel CPUs. Like, would this be very similar to how AMD?
Yeah. So Intel and AMD, I think, are very similar now. The important thing is about it for these kind of tests is how big the caches are and how they're laid out. And I've not actually looked recently, but I think AMD and Intel are quite similar. So yeah, I think that the same kind of thing will apply there. Yeah, I'm kind of using Intel as a shortcut for x86 at this point.
How do you kill with pipeline?
Oh yeah, that's a good question. So
like the iMac image has effectively like dead pixels off to the right, so that it's always a 32-bit or a 64-bit boundary.
Yeah, so it's kind of similar to this idea, which is where if you're, this might be a bit an extreme one, if this represented one row of your image, you would just pad it out with spare data so that each row starts on a cache boundary. I played a little bit with that on the project, didn't find a vast difference in performance in the end. I think it probably depends on the analysis you're doing, and modern Intel processors pay a lot less of a penalty for underlying stuff. So I was specifically looking at SIMD operations as well. So you can't really access them in LabVIEW. There's a couple you can, but you used to pay. What that does is you can pull in, say, 4 elements at a time, process all of them in a clock cycle, so you can get massive performance upgrades. And don't take this as gold, but let's say up to 5 to 10 years ago, you used to pay a big penalty if the alignment was off for that. More recent Intel processors, apparently that penalty is much lower, but I definitely think there would be cache effects if, depending on how you're, especially if you were going row by row. You know, if you were pick a row here, pick a row here, you're going to see some impact of that line.
I didn't know if the prefetch, where it goes and gets that piece of data, the way your top one, so your 3 bytes, are we going to run over on one so that it runs into the next?
Yeah. So yeah, so when this is an array, they'll be packed back to back anyway. So that will happen. I think it would be more if you're going to see that impact, I think, more if you were, when we're randomly pulling these out, because what you don't want to get here, for example, is every one of these you access. You can imagine if it had, let me get this right, if it's bigger than a cache line, if it ends up sat in the middle of a cache line, you've now got 3 cache lines you have to access. The first partial bit, the whole one in the middle, and the second partial bit. And so if you can push that alignment so that you know that it's kind of fitting in a full line, you could potentially cut the number of jumps and hits that you're doing there. especially if it's, yes, I think random access, that would be important. And I guess maybe if you're getting larger, that becomes more important because it's going to impact how many times you have to go out to the slower caches, I guess. I'm not sure. Yeah, I've had a little play with that, but not masses. And I didn't see a huge difference. And that play was in C. I've not played with it in LabVIEW. But I guess in LabVIEW you would just have to overshoot your array sizes to make that work.
The cache sizes on sale, where do you know what length or how many bytes of the
Yeah.
Is it like is it the transfer rate divided by the clock? Something like that? Is that
So the actual sizes.
Many rows, or sorry, you were basically saying a cache is a big log array. Yeah, it's just one D, isn't it?
Yeah.
Sliced up.
So the simplest thing to get an idea is they're actually shown in Task Manager, albeit in not the most useful way. What this shows is the full amount of cache I have, whereas these first two are actually per core. So it's how many, I forget how many cores I've got, 8. So you divide those by 8 and you should go back to those numbers that you had before.
So you could architect your data structures to be optimized against whatever cache you're targeting.
Yeah, that's it. So that was one thing we did look at on this project, was with these larger frames, was anything we can do that while we've got that in the cache, because I think on that system we had like a perfect 1 megabyte cache. It's like anything we can do to pack that in to make sure it stays in that cache while we're doing things on it, rather than moving on to another process is important. But yeah, these have expanded. This is kind of one area that isn't very publicized, but it's a big change from generation to generation. So going back a few years, you might have only had, well, like I say, that was like top end 8th generation Intel processor, I think, where you only had, oh no, but see, this is why this is confusing. I've still only got 1 meg per core, but it looks bigger because I've got more cores. Yeah, so that's now 1.25. Ignore that, I've got that wrong. Yeah, if you ever, the simplest thing if you want to find out for a given processor, in simpler terms, is just Google the processor name and you'll get a bunch of different websites that come up with kind of breaking down these specs a little bit.
Got to remember that you've got virtual cores as well, haven't you? So is that right? You know,
Yes.
If you get an 8 core, that's actually 16. So, is that right?
Yeah, that's right. Yeah, so hyper-threading, they call it on the internet.
Half it to say, you know, what the space is, so if you're trying to make your data fit. You know, there's only one bit of cache to take it up to zip.
Yes.
Yeah. What's virtual?
Yeah, so if you have hyper-threading enabled, I was reading about this yesterday, trying to get my head around it, funny enough, and I still lost. So it has the bare minimum duplication per core to support that. So both threads on that core would be sharing the cache still. So that's why certain processing loads you will find will run slower with hyper-threading enabled than if you disable it. And we found that on this application going back. It seems to be better now, or I'm not measuring it right. I'm not sure which. It's how you measure this stuff is the world into itself.
But Intel have been doing a lot with their speed boost, their boost technologies, where it actually analyzes what you're doing and ups the clock rate of a core. So that's what you get with something like the i7s. You can get a very much faster single core than the overall speed of the processor. So divert power, Scotty wise.
Yeah.
Well, there's a lot of stuff like that with the FPGA stuff. So I mean, obviously, like Intel's trying to make their stuff better and better, and at the same time, we're trying to get specific things out of it. But like certain things run faster single-threaded, so you want to run it in one thread so that it boosts that one core. And you can see this the processor speed changing all the time, but they're trying to thermally manage it. So running something in a single core faster, whereas if you're running splitting across multiple cores, you end up trying to like heat them all up, and you can't run them up to the same clock speed. But there's interesting stuff of like you want to try and like if you've got something that's single threaded, you want to run it on one core so that one core can clock up to the maximum speed. Because if you max out all cores, you essentially the speed drops down because of all the thermal management stuff that they put in.
Yeah, that makes sense.
So yeah, there's a lot of constant like game you're kind of playing
it's,
to like, beat the system. But
and the bit I've done no real research into is on top of all of this, you've got how LabVIEW wants to schedule it, because you have no control other than using time structures with where LabVIEW runs your code. It's going to split it into chunks to decide how to schedule that. And if you're doing something here and then decide to schedule it on another thread, then your L1 and L2 caches get blown, and you've got to start again with that, which I imagine it doesn't do that very often, but it's just something you can't really see how it's doing that way.
You mentioned that you tried C and Rust and LabVIEW. What sort of rough performance increase in your experience you saw from going from LabVIEw to C and Rust? Is it like a factor of 2 perhaps again?
It's very dependent on what you're doing, but probably more. There's a big biasing factor for that, which is that SIMD that I said earlier. So modern Intel processors have the ability to perform operations on not just 64-bit registers, which is what makes it a 64-bit processor, sort of, I think, but also to perform operations on 128, 256, or even now 512-bit wide registers. So, for example, you could pack 4 doubles into a 256-bit register and add a value to all of them in one clock. Now, LabVIEW does not expose, you can't do that in LabVIEW right now. It can do some floating point operations on 128-bit registers, and that's what that SSE2 flag is. So I don't know if you remember a few years ago, I said, oh, there's going to be a flag to say enable SSE2, and that is the name of those instructions for doing it. Anything where it can be vectorized, they call it, to use those SIMD operations, LabVIEW just can't touch it, because we don't have, it will not generate the CPU instructions that can do that so much faster. And so that, I mean, it doesn't give you a 4 times speed up, because as with all of these things, there's a bit of setup and a bit of tear down to kind of make that work, but it puts it at a big disadvantage for anything like that. Outside of that, it was surprisingly comparable. And actually what I've learned is there's lots of nice things that LabVIEW does to kind of help you do things the right way. So in C, if you're just indexing stuff out by calculating where you're jumping through, it's quite easy as a programmer to not think about the right way to access it. What LabVIEW does with for loops, by auto indexing in and out, is by default doing things the fast way. So, you know, LabVIEW was a lot closer to C in some places than I expected, but let's say it's very close to naive C, but once you start getting into the optimizations that are available and stuff like that, it struggles to keep up. But it can go a long, long way. That was kind of, with this project, I was surprised at how far we got with LabVIEW before we finally had to go. Now we're just going to do C. And a lot of that was to do with either the vectorization or being able to be faster to lose some pointers eventually. You know, in LabVIEW, you have a lot less control over where things are copied, and a typecast in LabVIEW is not a free translation. It does some checks, which is generally a good thing, but when you're looking to max out performance, it doesn't give it to you. The other problem with LabVIEW performance is getting stuff in and out. So the fact that everything is TCP files, it's text-based, is a massive pain in the ass for performance, because the text to byte translation, I can't quite remember how much, there was some kind of overhead there. So right now in that application, we're still doing that stuff in LabVIEW. But if they come back and say we need it faster, that's the next thing to go, is to start translating that into C. Or Rust. But yeah, so it's, LabVIEW is not a slow language, but it does not really compete with those when you really need to get every ounce of performance out. Any other questions?